Germany's only motorbike factory is located in the Berlin suburb of Spandau. BMW has been mass-producing motorcycles here since 1969.
The plant covers an area of 30 soccer fields.
This is also where BMW's two-wheel flagship is built, the S1000RR. Nicknamed the Double R, the 199 horsepower superbike consists of more than 4,500 separate parts. It is fully assembled in just 2 hours.
This is Champions League stuff.
The Double R's high-performance engine in particular is something very special. Its components are machined to an accuracy of 1,000th of a millimeter.
That's Formula One precision.
Production runs like clockwork. Every step is timed to the second. Working in close cooperation, people and robots manufacture up to 10,000 superbikes a year, as well as other two-wheelers made in Germany.
2,000 staff members here manufacture up to 800 motorbikes and scooters every day. That's one every 65 seconds.
Motorbike production in Berlin centers on the U-shaped assembly line, which has 62 fully automated carriages constantly traveling around it. Although it's similar to a conveyor belt, this high-tech transport system is far more intelligent and customized. Laid in the workshop floor are induction loops, which guide the driverless carriages. Along the way, the system records every work step and every part that is installed.
Each worker can also adjust the height of the driverless transport carriage, turn it, and also call the previous worker, for example.
complex and thus the most expensive part of the engine block. The automatic bolting control tells the mechanic the sequence in which the 10 bolts have to be tightened. Here too, the correct torque has also been programmed in. All the data are recorded. The timing chain is mounted and the camshafts inserted and pressed in place. Up to 140 of these engines are manufactured each day. Every work step is timed to the second. Finally, the cylinder head is closed with a sealed cover. To save time, many tasks in the motorbike factory are performed by automatic machines. This machine coats the edge of the dynamo housing with a synthetic sealant. The operation could never be performed as quickly, cleanly, and precisely by human hand. At the next assembly point, the superlight magnesium cover is bolted to the block. Every operation concerning the engine is recorded in the central data bank. Now the clutch is fitted, one of the last work steps in assembling the four-cylinder engine. When the engine has been fully assembled and sealed, it is put on a test rig. Every drive unit must leave the plant having passed this cold test. The technician attaches 8 lines to the engine. They will measure the air volume in the cylinders. Only when the cabin door has been closed can the test begin. The engine is powered up electrically to 2,000 revs a minute. In its interior, all the components are now moving as they would in the combustion process. The yellow hoses measure the air being sucked into the engine and then expelled. In this way, the intake of fuel and the expulsion of exhaust fumes are simulated. This engine is sealed and functions flawlessly. It has passed the cold test. After 2 hours, assembly is completed. Every opening is closed off with a safety cap to rule out any contamination of the sensitive engine. 2 bolts are attached to the sides to enable the 58-kilogram block to be lifted by a crane. The 4-cylinder online engine will now be suspended from a hook and taken for a ride. The lift provides access to a huge transport system under the roof of the workshop. Every engine built in Berlin first ends up in the loft. Installed up here is a complex overhead rail network. The superbike engine travels fully automatically through the labyrinth to its waiting position. Hanging in this depot are more than 600 engines for different types of motorcycles. They are waiting to be installed on one of the plant's assembly lines. This engine block is on the way to its destination, the RR assembly belt. The chain hoist takes it back to the production shop. This is the birth of a superbike. 34 assembly stations, and 2 hours later, the motorbike will be ready. At station number 1, the engine is connected to the exhaust system. The automatic transport system dispatches a carriage. The engine block is placed on it and secured. The base is ready. Next to be fitted is the frame. Made of aluminum, it weighs only 11 kilograms. Yet this lightweight is the motorbike's supporting structure. To cope with the huge forces occurring at nearly 300 kilometers an hour, it has to be manufactured with extreme precision. In the plant's own welding shop, the 4 cast aluminum parts that make up the frame are positioned on the welding table. The blank is turned and presented to the 2 welding robots. The robots travel along the weld edges with millimeter precision. At a temperature of 2,000 degrees, the electric arc melts the welding wire and fills the gap between the components. Each seam is welded twice.
Here, of course, we see a beautiful seam. Located beneath it is the main weld, the root seam, which is actually crucial for the stability of the frame.
The robots can weld 40 superbike frames a day. Yet despite their precision, the machines are not infallible.
The main job is done by robots, but since a robot always does the same thing, the quality has to be checked by humans. Final inspection is always carried out by a person.
The robots are fast and extremely precise, but because of their structure and size, they cannot reach every corner of the construction. These areas are then finished by experienced manual welders. After being powder-coated, the frame is given a serial number and a type plate. The black aluminum skeleton then moves on further to pre-assembly. Here, various lines and the wiring harness are installed. The workers can't afford to lose any time. The assembly line constantly needs replenishing. The transport carriage with the double R engine is already waiting for the marriage.
This is where the frame and the engine are married, as we say.
The aluminum bridge frame is slowly lowered onto the engine block. The first fixing bolts are tightened. Married, frame and engine enter the assembly line. The carriage is continuously in motion. Many work steps are performed with the fitters walking alongside. All the bolts that are tightened at this station have to meet high safety standards.
Here we have a bolt connection that is clearly safety relevant. The bolting is registered electronically, so we can always refer back to the databank to see if it was IO or NIO.
IO and NIO stand for in order and not in order. IO applies to a bolting whose measured torque meets the stipulated requirements. If a bolt connection is registered as NIO, the bike will get special treatment. Located at the center of the U-shaped production line is the pre-assembly section. It is here that certain units, like the front fork, are assembled and made available to workers on the conveyor belt for installation. The fitter inserts the front wheel suspension in the aluminum frame. Here, too, every bolting is registered. With a glance at the monitor, the fitter checks that all the nuts have been tightened correctly. In addition to the double R, 7 other motorbike models are manufactured on this assembly line. During one shift, the workers assemble various models, completing up to 220 bikes each day.
If we laid out all the assembly points in a straight line, it would be about 130 meters long. That's 34 basic assembly steps.
Motorbikes have been built in Spandau since 1969. But motorbike parts from the Berlin aircraft engine factory were already being delivered to Munich in the 1920s. Back then, motorbikes were highly popular and a cheaper alternative to a motor car. The sector boomed. Its technical innovations made BMW one of Germany's leading motorcycle manufacturers. Today, the concern is the country's only major producer of motorbikes and faces stiff competition from Japan and the United States. At the plant in Berlin, the next important components are being assembled. The rear swing arm and the suspension strut ensure stability on the road. At Assembly Station 7, the aluminum swing arm is mounted. Just like the frame, it was welded together beforehand in the plant. The height can be adjusted during driving operation with little effort. With a suspension travel of 120 millimeters, the central strut is electronically adjustable and can thus be adapted to any road surface. The hose for the airbox is secured with a kind of surgical clamp. The tools required for each operation are specifically stipulated. The fitter mounts the airbox on the engine. It's the bike's lung, filtering and regulating the intake air for combustion in the cylinders. For the next work step, the lifting column moves upwards. The aluminum swing arm is still naked. The rear wheel is still being prepared for installation in the swing arm. Wedge-shaped torque dampers made of hard rubber are inserted in the hub. They dampen the force created when driving off. The chain sprocket, with its 44 teeth, seals the hub and is pressed in place. The hoist saves the worker's back and guides the 12-kilogram rear wheel into the swing arm in a perfect fit. At 200 kilometers an hour, the wheel will rotate 28 times a second. The drive chain consists of high-grade steel that is super hard, yet at the same time elastic. It is riveted hydraulically. A mass producer like BMW also improves certain components and electronic systems in ongoing series production. So the R is constantly undergoing further development. To achieve this, above all, the firm's engineers need data and experience obtained from practice. That is why BMW cooperates with selected race teams, like NRT 48. At the circuit in Oschersleben, an 8-hour race is in progress. NRT 48 is competing in the Stock Sport World Championship with 2 Rs. The team has already practiced the pit stop hundreds of times. The wheels are changed, the tank filled, and the bike roars off again. In the Stock Sport class, there is a ruling that is highly important for cooperation with BMW.
We compete with bikes that are virtually production models. We are not allowed to modify the important components, the frame, the arm, the fork, the engine, and the intake silencer. So our bikes have the original harness and original lights. In other words, 90% of the parts are original components. From that perspective, the customer rides the same motorbike we race with.
During the race, the onboard computer records an enormous volume of data, which in the pit is made visible on a laptop. The cryptic diagrams and graphs provide information on the bike's weak spots.
I'm looking at how the front wheel loses speed when it's in the air. Basically, it's just to see whether the brake has operating clearance.
During the season, teams like NRT 48 drive hundreds of thousands of kilometers, always pushing their superbikes to the limit. Their vast experience also influences production at the Berlin motorcycle plant, where software updates or new electronic and engine settings will be implemented.
Developments from the cooperation flow back into the factory. In this way, we ensure that our developments in the motorsport sector are an open source. Every customer, private or professional, can benefit from our experience.
The S1000RR has been on the market since 2009. But it took tremendous efforts before the model could enter series production. The development process lasted several years. It all began in 2005 with a few pencil sketches. What could a new superbike look like? Performance and design have to harmonize. Sporty handling characteristics have to function not only on the circuit, but also in everyday traffic on ordinary roads. From the finished draft, a one-to-one clay model is produced, which serves as a template for all later scans and installations. Then what is known as a FEES model is milled. Weighing several tons, this metal pattern will be the template for most of the components in subsequent series production. At the same time, the engine is mercilessly pushed to its limits on a dynamometer. Vibrations, gear change behavior, and temperatures are intensified to limits far beyond what a rider could cope with. These tests provide important data for developers. The R reaches maximum performance of 199 horsepower at an engine speed of 14,300 RPM. The prototypes also spend hundreds of hours in a wind tunnel. At wind speeds of up to 300 kilometers an hour, along with aerodynamic properties, the temperature distribution on the machine is also optimized. Engine, transmission, and exhaust reach a temperature over 100 degrees. These parts can only be cooled by the headwind. Paraffin trails make the flow lines visible. The engineers test various fairings until they find the optimum balance between aerodynamics and cooling. On the test circuit, experienced test riders then analyze the handling characteristics of the new R. It is here that electronic assistance systems like ABS and traction control are brought to series production readiness.
I'm trying to tune the traction control so that a rider who is not so experienced will be able to handle the enormous engine performance, so that when he opens the throttle coming out of a turn and the rear starts to drift slightly, he doesn't take a tumble.
The prototype is then subjected to long-distance tests on the circuit. When they have determined the basic configuration of the R, the developers test camouflaged prototypes on public roads worldwide. In their design and performance, these bikes are the same as the future production models. The special paintwork makes it hard to distinguish the shape of the bike. On no account must the press catch wind of the new model and publish photographs prior to its market launch. Secrecy is still paramount. Over 60 test drivers put the bikes through their paces on all 5 continents and in all the world's climate zones. Since the superbike is to be sold worldwide, it must function perfectly in all weathers and in all road conditions. In the end, the prototypes will have been driven more than 1 million test kilometers. 4 years after the first pencil stroke, the R is officially launched. Up to 1,800 new motorbikes are registered each year in Germany alone. Basic cost, 18,000 euros. The oldest tract at the motorcycle plant houses mechanical production, a department of great importance. This is where the most complex engine components are customized for assembly.
Each day, around 4,300 parts leave here for engine assembly. This is where we manufacture the main components: cylinder head, crankcase, conrods, and crankshaft.
This places the highest demands on staff and on the high-tech machines. Precision tolerances are within the micrometer range, 1/1000th of a millimeter.
A human hair is about 70 micrometers in size. The human eye can still distinguish things between 30 and 40 micrometers, but we have to work to precisely 3 micrometers. That's the high-performance precision you associate with Formula One.
One of the precision parts is the conrod. Each engine has 4 conrods, which convert the up and down motion of the piston into the rotational movement of the crankshaft. So these cast parts have to withstand enormous forces. The blank is subjected to a series of work steps: grinding, drilling, milling, and reaming. Up to 2,000 conrods are manufactured here every day. In the cracking machine, the eye of the conrod is lasered to create a predetermined breaking point. A wedge then breaks into 2 halves. Through this special procedure, perfect form closure is obtained.
We do this because a broken surface fits together superbly one-to-one, and that's what you need in top-class motor racing.
Every conrod passes through this fully automated measuring cell. The robot weighs and measures the component with total precision. Just to remind you, later the engine will have 4 conrods. In shape and weight, they must be almost identical. Otherwise, powerful vibrations and imbalance could become manifest when the bike is on the road. So here the conrods are categorized and sorted according to weight class. The manufacture of high-performance components has a long tradition at BMW. The first motorcycle was produced in 1923. From then on, motorbikes got faster and faster. In 1929, on a BMW WR750, factory driver Ernst Jakob Henne set a world speed record of 216.75 kilometers per hour. In the years that followed, Henne set another 6 world records for the firm. The last one in 1937, when he reached 279.5 kilometers on a BMW 500 Compressor. But the young motorcycle manufacturing company also became involved in team sport, and in doing so underlined the suitability of its products for everyday use. The mechanical production department also manufactures the Superbike's crankshaft, again with micrometer accuracy. The cast blank is first turned to shape on a lathe. When the cheeks have been turned, the shaft enters a vortex milling machine. The bearing surfaces have to be perfectly round in order to absorb the enormous motive forces. This is where the 4 cracked conrods will grip later and accelerate the shaft to a speed of 14,300 revs per minute. When the gear wheels have all been milled and all the holes for the oil circulation system have been drilled in the crankshaft, it is deburred and cleaned with high-pressure jets. A fully automatic washing robot then takes up the contaminated crankshaft. Inside the washing chamber, the shaft is first given a hot full bath. Water at a pressure of 600 bar then deburrs every millimeter of the component. After a minute, the crankshaft is squeaky clean. At a temperature of over 600 degrees, nitrogen is introduced into the surface of the shaft in a hardening oven. The crankshaft is now extremely solid, but at the same time flexible. When it is cooled, the shaft is ground. The automatic grinder, too, works to an accuracy of 1/1000th of a millimeter. At Germany's only motorcycle factory, 110 crankshafts are manufactured per shift. Back to the conveyor belt. After 45 minutes, the structure already looks like a motorbike. It is now filled with coolant. This task, too, is performed automatically.
The unit performs a vacuum test to ensure that the cooling circuit is leak-proof. Then the vehicle is filled with the coolant.
While the coolant is flowing, the speedometer with its integrated onboard computer is installed in the handlebars. Together with the engine control unit, they are the Superbike's brain and monitor its functions. The machine has now passed the midpoint of the assembly line. Hundreds of individual parts have been installed by a dozen fitters. Quality control now ensures that no part has been forgotten or installed incorrectly. Inspection is still carried out by experienced staff, but now they are supported by high-tech robots. These two robot arms subject the bike to close scrutiny.
Here we have a so-called MRK quality gate. That's a human-robot collaboration. The robot also takes on individual control activities like checking that the correct rear wheel, the correct kickstand and so on have been installed.
The robot compares the structure with photos from the huge data bank. The sports bike is half completed. Induction coils laid in the workshop floor guide the driverless transport carriage. At walking speed, the RR heads for the second half of the assembly line. Filters on the last 65 meters of the conveyor belt are responsible for the fuel tank, the fairing, and the electronic system. The air intake is fitted to the front section. It's through this duct that the gas engine breathes. It's now that the RR is also given its distinctive face. The synthetic cockpit with its asymmetrical light system looks a bit scary. The fitters work at high speed, but also with great concentration. Nobody can afford to make a mistake, especially when, as in this case, the ABS system is attached. The engine and the airbox are the heart and lungs of the bike. Now it's the brain's turn. Via a data transfer unit, the onboard computer receives its software. That takes a while. So the unit remains connected to the machine through the end of the assembly process. Next, the exhaust system is bolted on. The men have only a specific time window for each work step. The motorcycle factory in Berlin runs like a well-oiled machine. And machines need fuel. The RR has a 17.5-liter gas tank. Since it is made entirely of aluminum, it weighs only 2 kilograms. The welding robots have produced the tank from 3 separate parts. The seams must not be bulky, but they must be absolutely leak-proof. Like every component coming from the welding robots, these tanks too are finished by human hand. This lady handles 50 fuel tanks a day. Her rotatable welding table enables her to reach every spot with ease.
Basically, I do what the robot doesn't manage to do. Like welding the small tubes and all the spots the robot can't get to.
Her biggest challenge is the aluminum the tank is made of. Its wafer-thin walls are only 1.5 millimeters thick, so melt holes have to be avoided at all costs. They would immediately turn the tank into scrap. After 10 minutes, this particular fuel tank is ready.
The manual welders need to be highly qualified and have a lot of feeling. This is Champions League stuff.
Each tank then has to be checked for leaks. The fuel tanks are filled with air in a special immersion basin containing distilled water. Since excess pressure is created inside each tank, any hole in the aluminum shell will result in air escaping and creating tiny bubbles. The 3D ultrasonic survey head searches for any such bubbles and approves or rejects the tank accordingly. These two candidates are fine and can be released for assembly. The cleaned and degreased tanks are placed on a frame. From here on, everything again takes place fully automatically. The containers enter the paint booth to be given their first coating. After 2 minutes, the 8 tanks are blue and end up on this colleague's table to be prepared for the next coating. But now certain areas have to be protected from the white paint.
This area has to be taped. And this area painted white.
So she will cover the places in the tank that have to remain blue. The red template provides her with fixed points for sticking the protective film. But first, she sprays them with water so that their position can be corrected slightly after application.
So macht das Tape dann nass. Ein bisschen.
I wet the tape a little, then put it in place on the marking.
The tape, the protective masking, is slowly stuck on the tank. It mustn't bubble or crease because later the red stripe will remain on the fuel tank as a decorative element. During spraying, the red film protects the upper side and the tank opening from the white paint. It takes only a few minutes to mask the tank.
The masking is now finished and the tank is prepared for the second color.
Along with 7 others, the tank now heads back into the spraying booth where a robot sprays it white in less than 120 seconds. When the paint is dried, the tank is given a layer of clear varnish. On the assembly belt, the painted lightweight tank is attached to the bike. Storing fuel is not the tank's only role. Because of its special shape, it also gives the rider stability on difficult bends. This can be crucial, especially on a racetrack. In Oschersleben, the qualifying race for the 8-hour event is underway. The private team NRT48 is refueling. Here, the fuel tank is not standard.
We can modify the tank. We're allowed to have up to 24 litres. So we have altered the basic original 17-litre tank to take 24 litres.
The team consists of 1 male and 1 female rider who alternate every 40 or 60 minutes. But there seems to be something wrong with the bike.
At first there was nothing, then just a little bit.
The input from the riders is tremendously important. The brake isn't working properly. It needs to be replaced. The team dismantle the brake calipers on the front wheel and replace them with a new set. Shortly before the long-distance race begins, other parts on the RR need to be replaced. This involves removing the underbody protection, along with the front fairing and the tank container. The men need access to the radiator.
We're exchanging the radiator on this bike once again. At the moment, it has a used radiator on it that has already been through one 24-hour race. It's a routine operation for us. We always have new material or material that's as good as new, simply to rule out any source of error.
The coolant circuit of a racing bike is filled with water. So in the event of damage, no oily substances can contaminate the surface of the track and cause other riders to skid. The old radiator is replaced with a new one. Finally, the NRT48, the 2 riders, and the RR hit the track. For 8 hours, they will lap the 3.7-kilometer long circuit in the battle for vital points towards the Superstock World Championship. Despite all the effort, victory has eluded the team. Still, the experience and the data gained over the weekend will benefit many riders on public roads. Germany's only motorcycle factory, in Berlin too, they're on the finishing straight. Now the Superbike's 13 fairing parts are being assembled. They give the machine its unmistakable appearance. Some parts are not quite finished. This side fairing comes with a special sticker. It tells every road user, here comes a RR.
If the tape is okay, no bubbles or creases, I usually rub it down ever so lightly. When it's finished, it is once again given a full coat of clear varnish in the paint booth.
The side element enters the fully automated spraying booth for a 3rd time. First blue, then white, and now clear varnish. Then the part is dried. This takes about an hour. At the BMW plant in Spandau, 6,000 fairing components for all types of two-wheelers are varnished every day. Every completed part then has a chip stuck to it. Together with the barcode on the transport tray, the part can be clearly identified, irrespective of its location. Before the two side fairings set off on a long trip, they are scanned and registered within the system. The tablet enters the plant's fully automated storage system. The transport belt is several hundred meters long and runs over several floors. Like a road network, it supplies specific workplaces with the necessary parts. Often the initial destination is the huge high bay store. It is 37 meters high. On 18,000 storage places, 90,000 components are waiting to be sent for further finishing. Down below, the almost completed Superbike now has the finishing line in sight. It is already leaving the U-shaped assembly line. The machine is now roadworthy, but it still lacks important fluids. Here, that changes. At the media loading station, the brand new motorbike is primed. Brake fluid is forced into the rear and front brakes. The oil circulation system is filled, and some fuel added to the tank. After about 4 minutes, the machine has been supplied with the basic fluids. Now the Superbike heads for the finish belt, where it is given its final appearance. The side parts, the windshield, 2 mirrors and the mudguard are installed. The double R is now complete. The driverless carriage takes the motorbike to the roller test bench. Over the last 2 hours, a Superbike of outstanding quality has been built from thousands of individual parts. It has an engine output of 199 horsepower and an engine capacity of almost 1 liter. The 6-speed transmission gives the double R a top speed of 299 kilometers an hour. Maximum torque is 113 Newton meters. Depending on how the bike is handled, consumption is between 6 and 8 liters of gas per 100 kilometers. With a tank full of fuel, the double R weighs around 200 kilograms. In its short life, the bike has already experienced 1 marriage. Now it even faces separation. Separation from the transport carriage takes seconds. From now on, the double R will proceed on its own 2 wheels. The driverless carriage goes straight back to the assembly line where a new engine block is already waiting. On the roller test bench, the bike is pushed to the limit. The test rider accelerates to 140 kilometers an hour and goes through all 6 gears. All the bike's functions are checked in line with a strict test report. Brakes, clutch, indicators, and lights all have to work perfectly, otherwise the machine will not leave the plant. In their own words, the experienced testers can tell through the seat of their pants whether a bike is running smoothly. The works has 8 of these test cabins, where up to 600 two-wheelers of all kinds are tested every day. A driver might test as many as 40 vehicles on one shift. The data connection is cut. The motorcycle has been technically approved. The double R is a complex, high-performance vehicle with a powerful internal combustion engine. In the foreseeable future, other propulsion systems like electric motors will play a major role. That is why BMW is already looking to the future with a concept vehicle and showing what a motorbike could one day look like. Emission-free drive units on an electric or fuel cell basis will be standard. They might not have the same throaty roar as a combustion engine, but a sound system could stimulate the sound of a racing machine. Where safety is concerned, there will be many new developments. This concept bike is equipped with a gyroscopic sensor designed to make a tumble impossible. But the technical highlight will be the networking of driver, motorcycle, and environment.
I can imagine that motorcycling in the future will have a lot to do with connectivity.
The vision is that all vehicles and road traffic will permanently exchange information on their position and speed. Collisions would then be foreseeable and thus preventable.
If a car detects a rock on the road, the motorcyclist will see that at once on his display. So we're talking about communication between motorcycle and car, with a car being braked automatically if the driver hasn't spotted the motorcyclist. These things will undoubtedly come in the future.
Assistance systems like these data glasses reflect all important information into the driver's field of vision. So there's no need for a glance at the speedometer or the rearview mirror. Another dream is that in future there will be no need for helmets either, because special motorcycle clothing will contain airbags and neck stabilizers. But with so many visions, no doubt many bikers will already be wondering just where the kick is supposed to come from. Well, maybe it's still possible to find a R lying around in some garage or other. This one is still hot from being tested on the roller test rig, so it's put in a giant fridge. The bike has to cool, otherwise the packing film could melt on the hot engine or the exhaust and stick. It takes the machine just 30 seconds to pass through the cooling tunnel. Most of the bikes head off to the customer in recyclable packing. The metal frame is reinforced with wooden lathes. The order and delivery forms are stapled on, and after a final control look, the machine leaves. In 95 seconds, the wrapping machine envelops the transport frame in a tear-resistant film. A labeling machine then gives the final goodbye kiss. 3 hours after the first work step on the assembly belt, the BMW S1000RR is loaded onto a truck. It is taken by road to the nearest goods station, container ship, or airport, depending on where in the world its new owner is waiting for it. In the meantime, work continues on the 130-meter-long assembly line. Day after day, 2,000 people and countless robots produce two-wheelers made in Germany. 800 motorcycles and scooters are manufactured here every day at Germany's only motorcycle plant.